continue with types of reaction. Now let's look at oxidation reduction reactions. Oxidation reduction reactions involve transfer of electrons from one atom to another, also known as redox reactions. This reaction involves changes in oxidation state, charges. Many involve the reaction of a substance with oxygen. For example, formation of rust. This is an oxidation reduction reaction. Combustion also is an oxidation reduction reaction. For example, if you burn hydrogen, it reacts with oxygen to form water. This is an oxidation reduction reaction. The reaction of sodium and chlorine to form sodium chloride. This is not combustion. This is also an oxidation reduction reaction because there is transfer of electrons. Electrons are transferred from sodium to chlorine, forming sodium chloride. Sodium is oxidized and chlorine is reduced. So this is sodium, this is chlorine, and a final product, this is sodium chloride. It involves transfer of electrons. So this is oxidation reduction reaction. So you see, the electron from sodium is being accepted by chlorine. So in definition, oxidation is loss of electrons and reduction is gain of electrons. If one atom gives off its electron, another must accept it for oxidation and reduction reaction to occur. Atoms that lost electrons are called oxidized. They are said to be oxidized. And the atoms that gain electrons are said to be reduced. So for example, sodium plus chlorine to form sodium chloride. Sodium is oxidized, so this is oxidation. And this is reduction. So sodium gives off an electron, then chlorine picks up the electron. Recall, oxidation and reduction occur when atoms change their oxidation state in a chemical reaction. Therefore, assigning oxidation state is important in studying oxidation reduction reactions. So let's look at some rules for assigning oxidation states. Rule number 1, free elements have oxidation state of 0. For example, sodium is a free element 0, chlorine is a free element 0. Rule number 2, monoatomic ions have oxidation state equal to their charge. So sodium plus, the oxidation state is +1. Chlorine minus, the oxidation state is -1. S2 minus, oxidation state is -2. And so on and so forth. That's rule number 2. Rule number 3, the sum of oxidation state of all the atoms in a compound must be equal to 0. So you see for sodium chloride. Rule number 3, the sum of the oxidation state of all the atoms in a polyatomic ion equals the charge on the ions. So for example, is the sum of the oxidation state of sodium and these 3 oxygen in this ion that makes it to be -1. So you see, 5 oxygen, +5 plus 3 into -2 is -1. Rule number 4, group 1 metals have oxidation state of +1 in all their compounds. Even K, +1. Rule number 4b, group 2 metals have oxidation state of +2 in all their compounds. Then rule number 5, in their compounds, non-metals have oxidation state according to the table below. So, fluorine -1, example of the compound that you said, hydrogen +1, you see it in methane, oxygen -2, you see in carbon dioxide, group 7A -1, group 6A -2, group 5A -2. So let's try to do this example. Determine the oxidation state of all the atoms in phosphate ion. Phosphate ion. So we are going to use rule number 3b. Which says that the sum of the oxidation state of all the atoms in a polyatomic ion gives you the charge on it. So 3b, so this plus this is this. So according to rule number 5, oxygen is -2. So -2, -3. So phosphorus now, -3 plus 8, because we have -8 here, is +5. So that's the oxidation state. Please, what is the oxidation state of each carbon, sulfur, and sodium in the following compound? Please try and practice and do this ones. Oxidation and reduction. Oxidation occurs when an atom's oxidation state increases during a reaction, and reduction occurs when an atom's oxidation state decreases during a reaction. In order to do that, you must be able to determine the oxidation state. So we follow the rules. According to rule number 5, the oxidation state of hydrogen here is +1. Oxygen is an element, is 0. -2. -2. Because in table 5, it is arranged in order of priority. And since we have this +1, and we have 4 hydrogens, so this is -4. This is 0. Since we have this -2, and we have 2, so we have +4. And here we have -2, so this is +1. So that is how you determine the oxidation state of each element in this compound. And that is it. So with this, you'll notice that the oxidation state of carbon has increased. So this is oxidation. But the oxidation state of oxygen decreased. So that is reduction. But hydrogen did not change. So nothing happened. Reducing an oxidizing agent. Oxidation and reduction must occur simultaneously. If an atom lost an electron, another atom must take them up. So the reactant that reduces an element in another reactant is called the reducing agent. That's the reactant that reduces an element in another reactant is called a reducing agent. It means the reactant that has an element that gives out an electron which is being picked by another element in another reactant is called a reducing agent. So the reducing agent contains the element that is oxidized. You know, when it gives the electron itself, it is oxidized. So the reactant that oxidizes an element in another reactant is called an oxidizing agent. So this reactant has an element in it that accepts an electron. Itself, the element is reduced. So for example, sodium plus chlorine. Sodium is oxidized, chlorine is reduced. So sodium is the reducing agent, meanwhile chlorine is the oxidizing agent. Assign oxidation state. Determine the element oxidized and reduced, and determine the oxidizing agent and the reducing agent in the following reaction. So the oxidation state of this is 0. The oxidation state of oxygen is -2. And the oxidation state of manganese, because this is -2 and the overall charge is -1, so -2 times 4 is -8. Therefore, the oxidation state of manganese should be +7. The oxidation state is a cation is just +1. In the product side, the oxidation state of iron is +3. Here, the oxidation state here is -2, and we have 2 of them, so this should be +4. Here, the oxidation state here is -2, and that of hydrogen is +1. So if you notice, the oxidation state of iron has increased. So that is oxidation. But the oxidation state of manganese has decreased. That is reduction. But our question is, assign oxidation state, determine the element oxidized and reduced, and determine the oxidizing agent and the reducing agent. So in this case, what is the oxidizing agent and what is the reducing agent? We said the substance that contains the element that is oxidized is considered a reducing agent. So based on that, we are assuming that iron is a reducing agent. And a substance that contains an element which is being reduced is considered an oxidizing agent. So that's the oxidizing agent, and that is the reducing agent. So please try and practice this. Assign oxidation state, determine the elements oxidized and the reduced, and determine the oxidizing agent and the reducing agent in the following reaction. Now let's look at combustion reaction. Please do this as practice at home. Try to practice this. Combustion reaction. Reaction in which oxygen is a reactant are called combustion reactions. Combustion reaction releases a lot of heat, a lot of energy. Combustion reaction are subclass of oxidation and reduction reactions. combustion product. To predict the product of a combustion reaction, combine each element in the reactant with oxygen. So if you have carbon combining oxygen, you have carbon dioxide or carbon monoxide. Hydrogen combining oxygen, you have water. Sulfur combining oxygen, you have sulfur dioxide or sulfur trioxide. Nitrogen combining oxygen, you have NO or N2O. Metals, you have the metal oxides. So write the equation for the complete combustion of CH3. So write the combustion reaction with oxygen. So you have this and this. Combine with each element to make a product. So combine carbon with oxygen, and you have carbon dioxide. Hydrogen, you have water. So that is what you get. Then balance the equation. So with that, we have come to the end of chapter 4. So please don't forget, check the questions at the back of the book. As usual, the odd number questions, the answers are at the back of the book. Thank you so much.